DevOps is a portmanteau that combines the words development and operations. DevOps aims to combine and merge development and operation teams together to rapidly build and deploy high-quality software. DevOps has a variety of best practices associated with it. Some of those best practices are related to culture and teams, while others are focused on build and deployment infrastructure. So today we're going to be focused on the infrastructure part. We're going to narrow in specifically on how to implement CI/CD. Okay, I keep using that term. So what is CI/CD? CI/CD stands for continuous integration and either continuous delivery or continuous deployment. Today, I'm going to be using CI/CD to refer to continuous integration and continuous deployment. Continuous integration refers to the practice of continuously integrating developer code to avoid conflicts. Continuous deployment refers to the practice of frequently deploying software. In order to benefit from CI/CD, you need to have a lot of automated tests that your team trusts. If the tests pass, your code will automatically be deployed. When your team utilizes CI/CD, you're able to get value to your end users faster. Many tools exist to help you implement CI/CD. Today, I'm going to be using Travis CI as it's a popular CI/CD tool that is free for open source projects. And who doesn't like free? Now let's talk about the second part of our equation, serverless. Serverless does not mean no servers. It just means that you, the developer, don't have to think about them. You write a function and the cloud provider handles executing the function on its own servers. In the serverless world, developers don't have to worry about servers, containers, or infrastructure. Instead, they get to focus on the application code. In a serverless architecture, you typically write serverless functions. Those functions can be triggered by various events, which could be a timed schedule, an authentication event, a database event, a call from the client code, or even a manual call. If you're used to working in a traditional monolithic application, in the platform as a service world, or in the containers world, this is a big architectural change. You no longer have long-running server-side applications. Okay, next up, what is MongoDB Stitch? Well, Stitch is a serverless platform that makes it easy to build modern cross-platform apps with MongoDB. Today, we'll be focusing on serverless apps that are built using MongoDB Stitch. Stitch is comprised of 4 separate services, and we'll talk about each of them briefly here. So the first is SDKs. Stitch has client SDKs for JavaScript, React Native, Android, and iOS that enable cross-platform client support. The second Stitch service is functions. Functions allow you to write server-side hosted JavaScript functions. These are standard ES6 functions that can be called from service actions, REST API requests, or our SDKs. Functions execute in a serverless way, so you aren't having to worry about hosting backend code on one of your own servers or some platform as a service. Next up, we've got triggers. There are 3 types of triggers: database, authentication, and scheduled. Database triggers monitor changes inside the database and then execute functions based on those changes. Authentication triggers fire when an authentication event occurs. And finally, scheduled triggers fire based on a predetermined time-based schedule. Last up, we've got Realm Sync. This service syncs data on your mobile devices. All right, one final term for you that you'll hear me talk about throughout this presentation. MongoDB Atlas is MongoDB's database as a service. It's fully managed by MongoDB, so you don't have to worry about any of the management headaches. Instead of trying to host my database locally on my machine, I'm going to do everything today in Atlas. Atlas has a really generous free tier that is great for development. Okay, so now that we're on our same page with our terminology, let's talk about why I'm giving this presentation. Why is implementing CI/CD for serverless apps so hard? Well, when I was implementing CI/CD for my app, I ran into 3 big obstacles. First, figuring out how to write tests for serverless apps can be really tricky. In fact, I had to do a lot of digging and eventually found a bit of a hack that let me write unit tests for my serverless functions. Second, researching testing frameworks can be time-consuming. And third, writing CI/CD infrastructure code can be tedious and a bit of a time suck. The thing is, doing all these things I just listed is work that doesn't provide value to your business. If you're a developer, I'm guessing you'd rather be writing code for your app instead of building the underlying CI/CD infrastructure. If you're a decision maker, you probably feel the same way. You'd rather have your team breeze through the infrastructure part and get right to building your app. Okay, so here's a quick recap of what we've already discussed today. CI/CD makes developing serverless apps faster and easier. And when you want to do that, you can use my digital binder to jumpstart the creation of your CI/CD infrastructure. Okay, so now that we're all on the same page, I want to demo for you the app that I've been building. Understanding what the app is and how it works will hopefully help you understand why I have architected my tests in the way that I have, and help you understand how my CI/CD infrastructure code works. All right, so I'm going to show you my social stats app. The app doesn't do much, but it solves a problem that we as a team were having. We wanted to be able to easily gather stats for how many people we as a DevRel team are reaching on Twitter. So let me jump out of my slides. Let me show you Twitter. So this is my analytics page on Twitter. So here I can see some stats about my tweets. Twitter even provides a way for you to download your stats for the last 28 days. So let me do that. I've got 28 days selected. I want to export my data by tweet, and it's going to start downloading my stats for me. So while we're waiting, I have prepared a dad joke, or rather a mom joke for you. If a child refuses to sleep during nap time, are they guilty of resisting arrest? I know that was bad, but I've been quarantined for 7 weeks with a toddler, so I can relate really well to that one. My kid's supposed to be sleeping right now, so hopefully we're going to have a quiet presentation. Okay, so here is my spreadsheet I just downloaded from Twitter. Here you can see my tweet ID, my tweet link, and a copy of the text that was inside my tweet. So here you can see I just posted about this webinar. So over on the right, you can see the stats that we really care about. Here we've got impressions and engagements. So impressions are how many people saw your tweet. Engagements are how many times someone interacted with your tweet. For example, an engagement could be a retweet or a like. These spreadsheets are handy, but we as a team need an easy way to roll these stats up. Things get a little tricky since you can only download 28 days of stats, and you want to make sure you aren't double counting stats from a previous download and that you aren't missing any stats. So I decided to create an app. And let's see if it's working now. This is actually the ugliest app I have ever created, so please refrain from hating on it. I know that it's ugly, but it works. It usually works. Today it's not working, but it usually works. So here's my file I just downloaded. We're gonna open it and hope that that file will be uploaded. So what the app is going to do is save the tweet statistics in a MongoDB database. The benefit to keeping things in a database instead of a spreadsheet is that I can programmatically take care of duplicate tweets to ensure I'm never double counting statistics and I'm always getting the most up-to-date statistics. So once that file is uploaded, I can click the link. Looks like I've got it open twice. I can click the link to open my dashboard. And here I have a dashboard with 4 charts that summarize my data. And they're loading slowly because it's a live demo. What else are they going to do? Load quickly? Okay, so here you can see stats for 2 of my teammates and me. So as you can see, things are a little out of balance here. It looks like Max has uploaded his March stats and he's having an amazing month. Way to go, Max. If I want to narrow the results, I can do that. So I can look at results for just myself. Let's see if that'll work. Okay, so here I can see some stats about me. I can choose to narrow the dates if I want, which is kind of handy. So if I want to just pull the stats for the month of February, which it looks like maybe I only have February stats uploaded in here right now anyway, but I could choose to just pull stats for the month of February, which is handy. I've got some nice numbers here that I can grab. I can drop those in my performance review to show how many people I'm reaching on Twitter. The nice thing here is that anyone on our team can come in to view these charts and filter them as they see fit, which is super handy. Okay, so that's my super ugly but functional app. So let me jump back to my slides. Here we go. So now that you have an idea of how the app works, I want to show you the app architecture as well as the CICD infrastructure. So let's begin with the app architecture. So when a user accesses that super ugly index.html page, they're accessing an HTML page that is hosted by Stitch. When a user uploads their CSV file with all of their Twitter stats, index.html encodes the CSV files and calls the process CSV serverless function. That function is in charge of decoding the CSV file and passing the results to the store CSV in DB, which stands for store CSV in database, that serverless function. That function calls the remove breaking characters function, which is a helper function that simply removes any bad characters from the tweets. That function passes the results back to store CSV in DB, and then store CSV in DB then converts the cleaned tweet statistics to JSON documents and stores them in MongoDB Atlas. Then the results are passed back up the chain and ultimately displayed on the web page. I moved through that fairly quickly. Basically, we've got a web page here that's hosted on Stitch. It calls a series of serverless functions, and it stores the information in a database hosted on Atlas. Now, when we view the dashboard with all the charts showing a summary of our tweet statistics, we are actually accessing a MongoDB charts dashboard. If you aren't familiar with charts, I highly recommend that you check it out. It's the easiest way to visualize your MongoDB data. So what's happening is that our dashboard is pulling data from MongoDB Atlas and then displaying it. All right, so let's slide that architecture diagram to the left of this slide and talk about the automated tests. I'm going to talk about the tests in the form of the test pyramid, which you may or may not have seen before. So at the bottom of the pyramid are the unit tests. The unit tests test each serverless function individually. I chose to use Jest for my JavaScript testing framework as it's a popular choice, but you could choose to use whatever testing framework you like. I find Jest to be fairly intuitive. Since these are true unit tests that do not test the integrations between a function and other code and systems that it interacts with, I had to create a lot of mocks. If you aren't sure how to create mocks in your test code, you can check out my GitHub repo or do some Googling, whatever works for you. The advantage to using mocks is that these unit tests can be run locally without accessing anything online. Now let's move up our pyramid to talk about integration tests. Our integration tests test the integrations between our functions and the database. My tests actually look quite similar to what I wrote in my unit tests, except instead of using mocks, I used the real integrations. Just as I did with my unit test, I used Jest as my testing framework. One important thing to note is that in order to test these integrations, my code must be hosted in a Stitch app. I do not have a way to run the integration tests against local code. Another important thing to note here is that these tests interact with my database. I've architected my tests to clear the database before every test, so I do not want to run these tests against my production app. At the top of my pyramid are the UI tests, UI standing for user interface, and some people call these end-to-end tests. These tests interact with elements on my index.html web page. The tests upload a CSV file with tweet statistics and then navigate to the dashboard to ensure everything was processed correctly. I've chosen to implement my UI tests using Selenium and Jest. Similar to the integration tests, these tests rely on code hosted in a Stitch app, so I cannot run these tests against local code. Also, these tests interact with my database, so I do not want to run these against my production app. So now that I've shown you how I've architected my app and my test structure, let's talk about how I move code from my local machine through various stages and into production. So I want to walk you through the stages of my CI/CD pipeline. I'm going to begin by giving you a high-level overview with diagrams so you understand what's happening conceptually. After I explain this, I'm going to demo it for you so you can see it in action. So let's talk about the 4 stages of my pipeline. First, I've got my local machine. This is where I do my development. I can write serverless functions and unit test them here. I can also create web pages and view them locally. When I'm ready to see how it all works together, I'm going to put the code in my development stage. So I'll talk about how the code gets there in just a moment, but the development stage is just for me and my code. Every developer will have their own development stage. When I feel good about my code, I can push it to staging. Staging is a place for all of my teammates to merge our code together and see what it will look like in production. If we want to do manual testing, this is where we do it. If all of the automated tests pass, the code will automatically be pushed to production. Now in my case, I have 4 stages. Depending on your team's requirements, you may have more or less stages than this. You might have different names for your stages. For example, some people might have a QA stage or a test stage. But here you can get the idea of what multiple stages look like, and you can tailor the stages for what works for your team's workflow. Now that we have an idea of what the stages are, let's take a few minutes to dive into the details. Because we don't want to have awkward, clunky movements between the stages. We want a nice, smooth pipeline. So let's begin by talking about how we can work locally on our machines. So first, I'll have a local copy of my development Git repo. The repo stores everything in my app, including my hosted HTML files and my serverless functions. When I'm working locally, I can run unit tests that test my serverless functions. Since I don't have a way to run Stitch locally on my machine, that's all I can test for now. I'll need to push my code to Stitch in order to run manual tests, integration tests, and UI tests. Okay, so how do I actually get my local code on Stitch? I'm going to push changes to my development repo. My dev repo is a forked copy of the staging repo. My dev repo is specific to me. My teammates all have their own dev repos. One of the nice things about Stitch is that it has a GitHub auto-deploy feature so that whenever you push changes to an associated GitHub repo, the code in that repo is automatically deployed to your Stitch app. So when I push changes to my dev repo, the changes will automatically be deployed to my Stitch app. That Stitch app will be associated with an Atlas project. The Atlas project is where my database lives. In my case, I chose to have separate Atlas projects for each stage so I could take advantage of the free clusters in Atlas. If you're paying for clusters, you can easily use a single Atlas project for all of your stages. Now, some of you might be wondering why I have a Git repo specifically for dev rather than using a single repo with a branch for each stage. The Stitch auto-deploy feature currently only allows you to auto-deploy from the master branch, so I need a separate repo for each stage. Finally, the Git push is going to trigger a Travis CI build. The build is responsible for running all of my automated tests. The build is going to run those tests against the dev Stitch app that was just deployed. Now, if you have experience with CI/CD infrastructure, this is probably going to feel a little odd to you. Travis CI is responsible for running the tests, but not for doing the deploy. So even if the tests fail, the deploy has already occurred. This is okay since it's not production, it's just my development environment. Okay, so before we move on, let's summarize what's happening here. When I'm done working locally, I'm going to push my changes to my dev repo. That push puts the code in my repo, triggers a deploy to my Stitch app, and triggers a dev build on Travis CI that runs my automated tests. All right, so now we're in the development stage. My code is in my dev repo. My code is deployed in my dev Stitch app, which is connected to my dev Atlas project. And at this point, I can choose to run manual tests against this deployment. I can also use my local machine to run automated tests against this deployment. When I feel like my code is well tested and I'm ready for a teammate to review it, I'm going to create a pull request. If you're not familiar with pull requests, I'll show you one when I get to the demo in just a few minutes. Basically, pull requests are a way for me to request that my code be reviewed and considered for merging into the team's code. So if my pull request is reviewed, let me start over. If my pull request is approved, it will be merged into our staging repo. The staging repo is a mirrored copy of the production repo. Again, we're using separate repos so we can take advantage of Stitch auto deployments. When my code is merged into the staging repo, it will be automatically deployed to my staging Stitch app that is associated with my staging Atlas project. The merging of my pull request is also going to trigger a Travis CI build. That build is going to run all of my automated tests. If the build passes, meaning that all of my automated tests pass, the build is actually going to automatically push the code changes to my prod repo. I'm going to come back to this in a moment when we talk about the push to prod. So just remember that this staging build is doing something special if everything goes well. Okay, so to summarize what's happening here, when my pull request is approved and my code is merged, my code will be in the staging repo, my code will be automatically deployed to the staging Stitch app, and the staging build will be automatically kicked off. All right, so now we're in staging. My code is in the staging repo. My code is deployed in the staging Stitch app, which is connected to the staging Atlas project. At this point, I can choose to run manual tests against this deployment. This stage is a simulation of production, so it's your place to do all of your QA testing. If I want to run the automated tests, I can use my local machine to run the tests against this deployment. All right, so now let's talk about how we move to production. Since we're following the continuous deployment model, we have a ton of automated tests. Our team has agreed that we feel confident that if the tests pass, we are ready to deploy. Now recall back to the staging build I talked about a moment ago. I told you that if the build passes, meaning that all of the tests pass, the build is going to automatically push the code changes to production. So instead of having a manual git push or a pull request trigger our move to production, we're actually going to have the staging build do the git push for us. So now our code is in our prod git repo. We still have the GitHub auto deployment feature configured, so that push to the prod repo is going to trigger a deployment to our prod Stitch app. That prod Stitch app is associated with a prod Atlas project where our prod data is stored. Finally, that push to the prod repo is going to trigger our prod build. The prod build only runs the unit tests. Recall that our integration and UI tests interact with our database, and we do not want to mess up our prod database, so we're only running our unit tests. In my case, the pipeline stops here. You may have monitoring or other tools or tests you want to run here. It all depends on what your team's requirements are. So one last time, let's summarize how we're moving from one stage to the next. If our staging build passes, it's going to push the code changes to our prod repo. That push is going to trigger a deployment to our Stitch app, as well as trigger the Travis CI build. All right, so now we're in our final stage, production. Our code is in the prod repo. Our app is deployed in the prod Stitch app, and our prod data is in the associated prod Atlas project. If we want to run tests, we can use our local machines to execute unit tests against the code in the prod repo. All right, so now that you have a conceptual view of how code is moving through the CI/CD pipeline, let me show you what it looks like in action. I'm going to make a change to the app and show you how the code flows through each of the stages. So let me exit out of this and let me kill Slack because people are talking to me. Okay. Alrighty, so let's see here. So after we upload a CSV file, we're going to get a nice little success message. And currently it says success, which is fine, but it's not very snazzy. So let me update that success message. Let's say fabulous instead. Okay, so since I'm working locally, I can run the unit tests just to be sure they are still passing. The unit tests don't touch my HTML files, so it'd be pretty surprising if something failed here, but it is a live demo, so you never know. Okay, our tests pass, which is good. So now that we feel good about our changes, I am going to commit them. So let me add a commit message here. So let's say something like update success message. Yep, I'm one of those people that likes to use the Git plugins rather than working in the command line. That looks pretty good. My changes look good, so I'm going to stage them and commit them. And I'm going to push that change to my development repo. We'll wait for that push to complete. Now let me hop on over to Stitch. Let's see, I'm in the wrong app. So let me jump over to my dev project. Open up my Stitch app. And I'm going to jump on over to the deploy page. So here we can see that my deploy was successful. That's good. That's today's date. So my deploy was just kicked off at 1:07 p.m. So that's great. So we saw the deploy was successful. That Git push is also going to kick off a build on Travis CI. So we can see here that my build has been kicked off, which is great. It's been running for 18 seconds. Okay, so the build takes about 1.5 minutes to run, depending on how things go. So while we're waiting for the build to run, I want to show you the hack that I used to write unit tests for my serverless functions. So let me open up a serverless function for you. Here we go. This is my remove breaking characters function. It's a really short function that uses a regular expression to remove certain characters from text. By default, Stitch serverless functions look like this. They're required to be of the format exports equals function, blah, blah, blah. So they all have to start like this. The problem is that there is no way to call this function from another JavaScript file. So what I did with the help of one of the Stitch engineers was add these 3 lines here to the bottom. And what this does is it allows me to access the exports in this file. So let me open up the unit test that tests this one. So I'm going to my tests, my unit directory. Here's remove breaking characters. And you can see at that top line, I'm able to import the remove breaking characters file, which is nice. So you don't need to memorize those 3 lines here, obviously, but if you get stuck trying to figure out how to unit test your serverless functions, there's that hack in my GitHub repo that you can borrow. All right, let's jump back to Travis CI and see if my build finished. Oh, it's running extra long today because it's a live demo. What else was it gonna do? So let's see what's happening here. I'm gonna scroll down a bit. All right, looks like my UI tests are getting kicked off. And it looks like my UI tests have failed. Woohoo! Oh, and some of my unit tests have failed. That is all fantastic news. Okay, let's go try and fix the UI test. Let's start there. I went through that very quickly. Let me stop scrolling for a moment. We can see down here at the bottom, this is a snapshot of my test that failed. Jess does all of this for me. I didn't make this. So we can see we have a lot of test failures. Let me start with my UI tests and see what's happening. So we'll scroll a bit. Okay, so in my tests, I actually test my success message, which is good. So let me go ahead and update. So instead of saying success, I said fabulous. And let's scroll a bit. Okay, I do this a couple times, which is fabulous. Okay, let me save that. And let's run, instead of just running the unit tests here, let's run all of the tests. So I'm gonna remove this section here that's saying only run the unit tests because it's drilling down on the unit test directory. Let's run all of our tests and we'll see what happens. typically the tests run pretty quickly, maybe about 30 seconds or so. When they start taking longer, that typically means something is failing. And as my friend Otto said, when I tested this with him, he said, what would a demo be without a failure? And it seems that's a situation we have here. We've got some test failures. So what I'm going to do is I'm going to be a bad developer, and I'm just going to say, you know what? I don't care that my tests are failing. We are going to push on anyway. So, you know, don't do this in real life, but that's what developers do sometimes, right? They're just like, I want to push my code even though the tests are failing. So I'm just going to do that. So what I want to do is I'm going to just fix these UI tests. So fix UI tests for new success message. Let's take a look before I commit those changes, make sure they make sense. I'm going to commit those, and I want to push those to my dev repo. Let me jump back on over. Let's check on our deploy. I'm going to refresh that. Okay, we've got a new pending deploy. That's good. And I'm going to scroll back up to my Travis CI page to check on this build. Looks like I'm going to go over to the build history, and we can see my build has been kicked off. That's the right commit message. So we will wait for that to run. Okay, so while that build is running, I want to show you a tool I wrote that you might find handy. So let me jump over to Atlas. So this is Atlas. This is where my database is stored. Atlas allows you to whitelist IP addresses so that only those IP addresses can access your database. This is a fantastic security feature to keep random people from accessing your database. The problem I ran into is that I need my automated tests to be able to access my database, and my automated tests run on Travis CI. So I need to whitelist all of Travis CI's IP addresses. And as you can see here, Travis CI has a lot of IP addresses. So I wrote a script that pulls all of Travis CI's IP addresses and whitelists them in your Atlas project. So that script is available on GitHub. It's in the MongoDB developer organization. It's called Travis CI IP address whitelister. So I'm not going to get into the details of how to run it now because all of the instructions are here in the README. And basically it makes use of the Atlas API, and it pulls the Travis CI IP addresses and then uses the Atlas API to set them to be whitelisted. So you don't need to know the details. I just want you to know that it exists so that when you start creating your builds, you don't have to sit and manually type 50 IP addresses when you want to get your tests running in a Travis CI build. All right, let's take a look at our build that should hopefully be finishing soon. Again, the fact that it's taking longer than 1.5 minutes is not promising. So let me scroll all the way down to the bottom, see what's happening in our build. Okay, great. We've got more random test failures, which is fantastic. Okay, so looks like my UI tests are still failing, but I want to make sure we've got time for questions. So I'm going to move on and pretend that things are passing. So let me just show you what a passing build looks like. So everything was working beautifully last night when I tested this. So here's what it looks like when a build passes. Down at the bottom, we'll see everything passing, and it's great. So we're going to pretend like that's what just happened. So what I want to do now is create a pull request. So when I feel confident in my changes and I'm like, yes, things are good, my tests are passing, I feel good about my code, maybe I've done some manual testing, I want to create a pull request to merge my code into staging. So here I am in my GitHub repo for my dev environment, and I'm going to click New Pull Request. So what I'm doing here is requesting to merge my changes from my dev repo into my staging repo. So I can scroll a bit to see the code changes I've made. These look good to me, so I'm going to choose to create a pull request. So here I could write a helpful message, be a good developer, and write something like update status message. I could leave a comment. I could assign this to myself, and here I could assign a reviewer like Karen to take a look at my code. But for simplicity, I'm just going to leave the reviewer blank and create the pull request. So here's where someone else on my team, like Karen, would come in and view my pull request and choose to either approve it or reject it. They can check out what files I've changed. They can view a list of my commits. They can add inline comments. They can add comments here for me and then say yes or no. So if they approve it, they're going to choose to merge my pull request. And I'm going to confirm the merge. So once again, my code will be deployed automatically to my Stitch app. And this time it will be deployed to my staging Stitch app instead of my dev Stitch app. And my staging build should be automatically kicked off for me. Let's take a look here. That's my prod build. Here's my staging build. Let's look at the build history. And here you can see there's a new build to merge the pull request. While that's running, I want to show you the magic behind these builds. So every Travis CI build is required to have a .travis.yaml file. So let's walk through what's happening there. So I'm going to jump back to my code editor. And let me make this one bigger. See if we can read it. Okay. So as you can see at the top, we're using Node for our builds. We're using the Chrome add-on so we can run our tests in Chrome. Then we're starting up the Selenium server, so we will be able to run our Selenium tests. Those are our UI tests. Next up, we're installing the Chrome driver that our Selenium tests will need. Once we've got everything installed, we're ready to run our tests. If we're in the social stats repo, that's my production repo, we only want to run the unit tests. So I'm kicking off my Jest tests here, but I'm specifically saying only run the tests in the unit directory. If I'm in any other repo, I want to run all of my tests, so else run everything. Finally, if the build has passed and we're in the staging repo, we're going to push our code changes. So we'll say, if we're in the staging repo, then push changes to my production repo. So this right here is what's actually triggering the prod, build, and deploy. Let me jump back to see if that build has finished. And my guess is that since everything else has failed, this is probably going to fail as well. So I'm going to just go look at the build history and show you what happened when I did this 21 hours ago, not too long ago. Down at the bottom here, you can see all of my tests pass. And we're doing that check to see if we're in the staging repo, which we are. And it's doing the push to production. And that's what's actually going to trigger my prod build. So let's take a look. Yeah, my build failed. My builds are angry. The builds were angry that day, my friend. Okay, so now you've seen how code can move theoretically from my laptop to dev to staging to prod. I utilized Stitch's automated GitHub deployments as well as Travis CI to create my CICD pipeline. Okay, so let's wrap up this presentation. So 2 big things I want you to remember when you leave here today. CICD makes developing serverless apps faster and easier. You can use my digital binder to jumpstart the creation of your CICD infrastructure. Here is a link to the GitHub repo where all of my code lives. The README has detailed explanations of the app architecture as well as the CI/CD infrastructure. And it goes into detail to basically everything I've covered here today. If you're not familiar with the MongoDB Developer Hub, I highly recommend you check it out. It's where developers can find all of the resources they need to develop on the MongoDB platform. And my team actually contributes to the blog there. I'm working on a blog series that's going to eventually be published on the Developer Hub that will cover everything I talked about today. So if you want to get notifications about when the blog series is published or grab a copy of today's slides or watch my silly TikToks, you can follow me on Twitter. And my handle is Lauren_Schaefer. So, are you ready to create your own CI/CD pipelines for serverless apps? You've got your binder and you're ready. All right, I've got 2 announcements for you here before I kick off the Q&A. First up, I've got a promo code for Atlas. So you can set up all of this using the Atlas free tier. When you want to move beyond the free tier, you can use promo code Lauren200 to apply $200 of Atlas credits to your account. So again, that code is Lauren200. Second announcement, as a heads up, Stitch will soon be renamed to MongoDB Realm. This is just a name change and there will be no breaking changes. If you want to get updates on the rename and when the beta product will be released, you can sign up for notifications using the URL on the screen, which is mongodb.com/realm/subscribe. And with that, I am going to kick off the Q&A. And Karen, I think you've got, Karen, can you help me out? Are there questions that you want to queue up for us?
Yeah, there are. So I actually put some behind the scenes. If you guys want to know the magic I've got going on, I've got a doc where I sort of copied some questions that people asked along the way. And I might have, if I was trying to answer all I could in the Q&A, and I might have said, Lauren's going to jump back into this. Can we leverage Jenkins with Stitch?
Oh, certainly. I have not tried it out myself, but the idea would be the same. I've used Jenkins in the past, and you would just need to set up an environment where you could kick off your tests, and then you could kick them off, very similar to how I do here. So you would not have a .travis.yaml file. You'd have to write your own script to kick that sort of thing off, but definitely possible.
A few people have asked for the presentation and for the links to the GitHub. Oh, there's the link to the GitHub again. Okay, and there's the link. Okay, great. You thought of that. My bad. Let me see. So Vuk asks, and I don't know what TF means, but he says, is there a resource manager which might be used as part of the CICD for provisioning resources? We write TF and have made our own.
You know, Luke, I'm sorry, I'm not sure. I do not know what you are talking about, but I'm very curious. So I will do some Googling after this and find out. Unfortunately, I don't have background information on that.
Yeah. Let me see. So if you guys wanted to keep asking questions in the Q&A, let me know. Just some general ideas and takeaways about best practices for testing serverless functions. I know you went over everything quite detailed, but if you could just kind of maybe sum up a quick takeaway from that. I actually didn't know, as an aside for people who are listening, I didn't know any of this stuff, so I just suffered. I just suffered through testing all my serverless functions, and I saw this presentation like, oh, that's how you do it. That's how better developers do it than me. So.
Yeah, it's amazing how much more comfortable you feel making changes to your app when you've got the automated tests. And even like my app is crazy simple, but I would be like, oh, let me make a change. And then I would just run my automated test and I would go, okay, it's fine, without having to go test everything myself, which is nice. So I think as far as best practices, I think what I've heard a lot of people do is they will create the integration tests as their biggest test layer. And so, because serverless functions are typically very small, people want to test those integrations between them. I know a lot of people do not create, or I've heard people don't create the unit tests as much, and I'm not sure if it's because they don't know how or they don't see as much value in them. I like the safety net of unit tests. Mocks are kind of a pain to set up, but they are doable. And so it's possible. And as much as you can create a safety net for you and your team, once you start building that test infrastructure, you can move so much faster.
Itziak asks, can you show us where you put Atlas information in your project?
Let me think. So I have a config file, and in here, I've got a test.environment file, and I'm trying to remember exactly what's in it. And so I'm not going to show it on this demo, so you guys don't start wreaking havoc on my project. But basically, I've got a test.environment file where I've got all of my variables. And let me open up the repo real quick. And inside the repo, I tell you exactly what variables to set there. Here at the top, towards the top, I've got a list of project variables. And so I've got just a list of all of my variables that I need. The other place that I had to set it, which is a little strange, is inside of Stitch. I had to create a config.js file because Stitch needs to know which app to connect to, which Stitch app to connect to. And so this is a little hacky, and honestly, it's pretty ugly. But it goes through and says, if you're using this app, then you need to connect to this charts dashboard. If you're using this app, you need to connect to this charts dashboard. And I'm actually pulling that Stitch app ID out of the URL, which is kind of hacky. And so I talked with the product manager of Stitch, and they are definitely aware of this problem. And so hopefully a fix will be coming soon so that there will be app awareness, so you don't have to do hacks like this.
I think we'll always have to do, like, not necessarily, it's just a development thing in the world. That's just what it is. So, let me see. So Atlas, let's see, I think that might be everything. Oh, Terraform. Okay, so Vuk was asking, I'm going to go back to Vuk's question. Thanks again for clarifying, Vuk. He was the one who asked, and I don't know if this is helpful to you or not, it's not my space, but is there a resource manager which might be used as part of CICD for provisioning? They use Terraform.
Okay, I know that Melissa, who I'm totally spacing on her last name.
Plunkett.
Thank
She
you.
is a Terraform goddess. Actually, if you don't know Vuk, you can just, and I'll type it in your thing. You can just email me directly if this isn't helping you, and I'll take it offline with you, and I can get Melissa to chime in when we get there. But if we've stunned Lauren on this one.
Yes, I know there are Terraform resources, but that is the extent of my knowledge. So I think probably even if you Google Stitch Terraform, probably something she's written will come up.
Yeah, and just as an aside, everything that you could do in Atlas, everything that you could do in Stitch, it's actually all based on API. So any button that you press, anything you do is based on an API. So it integrates with all sorts of different platforms. And you can automate basically everything. I've yet to find something I can't automate. So. Okay. Do you recommend, so one last question from Itziak, do you recommend different clusters for different branches?
Do I recommend different clusters for different branches? Yes, you are going to want a different cluster for each branch. I'm sorry, I'm going to assume what you're asking is, do you want a different cluster for each stage? And the answer to that is yes, you do want a different cluster for each stage, because you want to be able to have your databases named the same thing in each stage. So you aren't having to like write more hacky code that's like, if you're in this version of the app, use this database name. If you're in this version of the app, use this database name. So you do want to have separate clusters so you can just keep consistent naming throughout. So you aren't having to worry about testing for specific cases and making all those changes in your automated test code as well as your deployment code.
Okay, great. Lauren, thank you very much. As to everyone, I will say that I've seen this presentation before, and those apps were working. I don't know what happened, but that's just the way it is sometimes with the demo gods. So it's a global pandemic, so not funny. So Lauren, but after your dad joke, I'll make another uncomfortable joke.
Awesome. Karen, thank you so much for doing the QA, and everybody, also thank you for coming, and I hope you enjoyed it.
I think if Melissa's on, I think she posted a poll. I actually don't know where that is, but if you guys saw poll, oh, there you go. Thank you. If you guys saw poll, we would love your feedback and know how to make this better. Did we mention Mongo Live? Lauren, did you mention MongoDB Live in June?
I totally did not. Let's talk about it.
Go ahead, I'll let you do it. Because Lauren's doing this, are you doing this presentation at that?
Yes, yes. I'm doing this presentation. MongoDB Live, I believe, is June 9th and 10th. It's online. It's totally free. So you can register today. And I would recommend going ahead and putting it on your calendar. Like, I don't know about you guys, but I have been kind of putting off professional development. Life has been really chaotic for me. And so if I can go ahead and block off the time, that's good for me to do. So go ahead and register. Karen, what are you talking about it live?
So there are a variety of talks that we're doing there. I'm doing it. We're going to announce all the things new MongoDB. If you've ever heard of or gone to MongoDB World, it's always in New York. It's our biggest conference of the year. And this year we're having it online instead of in person. And my talk is going to be, I do MERN and MEAN apps and how to sort of leverage Stitch on the back end. So you could move it off of Express and Node and host everything in Stitch, which is, it's fun. It's a fun workshop. So it's a live workshop if you want to code along. But we have tons of different content about how to make your clusters more performant, all the new Realm stuff that Lauren mentioned. We're going to have workshops on that. All sorts of workshops and all sorts of different things, everything related to MongoDB, including all the new stuff, which includes Data Lake and a lot of the new aggregations that we have coming up. So search, Atlas search,